It is Naveen joining the call. Can you guys hear me? No, very good. Good evening, guys. It's Naveen joining the call. Can you guys hear me? Could you please type in a yes, please? Great. Thank you, guys. So let's get started here. Hope you can see my screen now. And there it is. Today we'll be talking about another machine learning algorithm. I will be introducing you to another machine learning algorithm, and we'll try to understand the significance of it, guys. Okay. Yesterday we talked about linear regression. Linear regression, it uses the best fit line. The line is as close as possible to all the points, is what we have briefly discussed. And using the principles of mathematics, we are now able to make the business decisions, guys. That is what is the greatness of the machine learning algorithms. So today the entire world is trying to understand the principles of these mathematical algorithms and trying to see how to apply these algorithms in their business data and see if they can make business decisions and things like that. That is where the greatness of it lies, guys. So that's just a quick review. Let's go ahead and get started with clustering, guys. Let's say, come here. Okay, so what is clustering? Clustering, it is about organizing the data into clusters. Clusters means groups, such that there is high inter-cluster similarity, which means within a group the similarity is high, and low inter-cluster similarity. Inter-cluster means between the groups the similarities are low. What does that mean? That is what we'll try to understand. Informally finding natural groups or nature's groups. What is that? That's what we'll try to understand. Okay, so why do we want to do it? We'll also try to understand that. But let's see, here is a friendly way of understanding what is clustering, guys. Imagine we have a group of weights of few animals. We also have the heights of few animals. Let's say here is one animal which weighs 1 kg. Let's say it about 10 centimeters in height. There is another animal which is 1.2 kgs in weight, and let's say that's about 12 centimeters in height. Then you have another one with 1.4, and it weighs about, let's say, 14 centimeters in height. And let's say we have a lot of such animals where we have the weights and animals, weights and the heights. Imagine we give this one to an algorithm. This is the algorithm. We're taking the data, we're giving it to this algorithm, and imagine what the algorithm is going to do. Is it's going to do something like this. Visualize. This is the y-axis, this is the x-axis. The weights are drawn here. Here is the weights. Let's say start with 1 kgs weight. Let's say this is 2. Let's say this is 3. And it continues. Then you have the heights here. And let's say this is, for the sake of simplicity, 10 centimeters is the height, 20 centimeters in height. And just visualize the heights are increasing like that. Now let's take the first set of first animal. Let's say it's 1 versus 10, so roughly it will come here. 1 kg in weight, 10 centimeters in height. Another one is 1.2, let's go ahead and put it here, roughly. Another one is, let's say, coming here. And let's take a few animals which are somewhere over here. Their weight is somewhere from 3 to 4 or 3 to 5 kgs in weight. And there are a few animals, let's put them here. They're somewhere around 2 kgs in weight. Height is maybe between 20 and 30 centimeters. Let's take few more animals whose, let's say, weight is between 1 to 2 kgs in weight, and maybe their height is more. And here there are some animals where their weight is more and height is more. So what is this? This is what the algorithm is doing. Once the algorithm plots them, let us say, for the sake of simplicity, we start with this one. Here is the first group it forms. The group is called a cluster. Here is the second group it forms. It is a cluster, second cluster. Then here is, let's say, the third one. Here is, let's say, choose this one. Say, choose this one, fourth one, and let's say, here is the fifth one. Now, if you closely look at this groups or clusters, what it is indicating is there are some animals whose weight is around 1 kg in weight, and they are between 10 to 20 centimeters in height. Can you think of any animals which weigh maybe 1 to 2 kgs in weight and 10 to 20 centimeters in height, guys. Can you think of animals? 1 to 2 kgs in cats, okay, acceptable. Cats, birds, good. Think of any animals which are maybe, let's say, 3 to 4 kgs, maybe 3 to 5 kgs in weight, but the height is only 10 to 20 centimeters, which is the green group. Dogs, okay, acceptable. Okay, rats, okay. We can go with rats. Think of any animals where the weight is less, but the height is more, guys. Squirrels, birds, rabbits, goats. Okay, more precisely, how about cranes, guys? Well, we can call them as cranes. And think of any animals where they're somewhere in the middle. Their weight is somewhere in the middle, and kangaroos, tigers, okay, acceptable. Okay, let's say, think of any animals where the weight is more and the height is more. Humans. Good one there. Giraffes. Elephants. More precisely, giraffes, elephants, their height is more, their weight is more. So what is happening is, gentlemen, ladies, your algorithm has separated, we can say that your algorithm has separated the cats, dogs, let's say that is horses, this is elephants, and this is giraffes. What is that? That is, these are nature's groups. What is that? That is what the algorithm is doing. What is it doing? It is separating, it is creating groups. When you look deep into the groups, what is happening is, you're observing all the cats and dogs, giraffes, horses, and elephants are getting separated. How? Mathematically. How does that work? That is what we'll try to understand today, guys. This is what is called clustering. Okay, now imagine, for the sake of simplicity, let's come back here. Instead of weights and heights, think of this as wickets. Think of this as runs. The data is different. The concept is same. Okay, so what is the mantra? The mantra is, if you know how to drive a car, you can drive any car. What is important is you know how to drive the car. If you learn the Ambassador car, you can drive a BMW and a Benz. So what is important? Learn to drive a car. What's happening? The concept is same. Driving is same, but the car is different. So the data is different. We apply the same concept. In other words, if we were to give wickets and runs to an algorithm, let's see what it does. Now take a look at this group. It formed these groups. Okay. And what is special about the blue group is, these are the group of cricketers where they are taking less number of wickets and they are scoring less number of runs. Take a look at this one. These are group of cricketers where they're taking more number of wickets but scoring less number of runs. And this is, let's say, take the pink group. These are somewhere in the middle. They're average. They take average number of wickets and they score average number of runs. Then again, this is a group where their wickets are less and their runs are more. That is the black group. Then you have the yellow group where the wickets are more and the runs are more. Can you think of a group of players where they're scoring more and taking more wickets? What do we call them in the world of cricket? They hit more runs and they also score more. What do you call them? They're all-rounders. They're not just all-rounders, they're very good all-rounders. Okay. Think of the group of players, the black group, where they take less wickets but score more runs. What do you call them? They're more into runs than wickets. They don't have a lot of wickets, but they score a lot of runs. What do you call them? They are not just batsmen, but they are good batsmen. Okay. Next, come here. Take the green one. They're taking more wickets, but runs is less. What do we call them? They are good bowlers. They are maybe the best bowlers and things like that. The pink is somewhere in the middle, so they are the average bowlers, and the blue ones, we can call them as below average. They take below average wickets and below average runs. Everybody with me, guys? Catching it? So what's happening is a different story is evolving. Okay, you give different data, the concept is the same, but you're able to tell a different story, you're able to understand a different thing. What is this? This is a slightly friendlier look at this one. Let's take a slightly formal look. Now, what we are saying is, they have high intra-cluster similarity. What it means is, imagine these are cats. The blue group is cats, and let's say the green groups are dogs. What is special is, what we are saying is, the cats are very similar to each other. But between the cats and the dogs, their similarities are less. What is that? Because the cats are very similar to each other, it is high intra-cluster similarity. Similarity is very high. And the similarities are low. What is special? Between cats and dogs, the similarities are low. So that is, inter-cluster similarity is low. And what is this? These are nature's groups. Cats are found by the nature. Dogs are found by the nature. Okay, we call them as natural groupings. These are found based on the principles of mathematics. How? Let's try to understand that. Everybody with me so far? Can you give me a quick yes? Okay, so now let's get into the details. So why clustering? Why is it important? Well, let's see what we have here. Clustering, organizing the data into clusters, which is nothing but groups. Groups shows internal structure of the data. So if you take genomic data and things like that, which is healthcare related and things like that, you can understand the groups of genes and things like that, and you can that will help the medical medical or the healthcare people understand many. These patterns will help them in understanding the domain a little bit more. And there are a lot of uses, guys. I'm not an expert in the genomic data, but here is a slightly more important one, which is market segmentation. What is market segmentation? That is what we'll try to understand. We'll try to do a case study. Partitioning is a goal. In other words, we'll take the customer's data and we'll try to come up with these groups. These groups will act like hidden patterns, and we are able to tell a story that is referred as market segmentation. A very, very popular scenario, guys. Okay. Clustering is also used in AI techniques. When you search something in Google, Google is using clustering as one of the algorithms in showing you the results. The techniques for clustering is useful in knowledge. The knowledge is nothing but the hidden patterns. Okay, they are underlying rules. They are hidden. They're reoccurring patterns. In other words, they are hidden patterns again is what it is, guys. Okay, so that is slightly at a high level of why clustering. But let's get a little bit deep into the technical. What we have here is, if you go back to school, a vector. Vector is something which has magnitude and direction. Direction is the angle of the theta. If you take a look at this one, A, B, C, the red, the green, and the blue, they are three different vectors. All the three of them have the magnitude and the direction. Magnitude is again a Pythagoras theorem. Hypotenuse square is side square plus side square. So clustering makes vector as a fundamental concept, fundamental principle in coming up and identifying these groups and groups, guys. How does it do that? Let's try to understand that. It uses two things, which is similarity by correlation, similarity by distance. When it is identifying all the cats, when it is identifying all the different groups, it is comparing. It is making some comparison and measuring them. It is measuring. You can measure it using correlation, or you can also measure it using distance. If you recall from yesterday, day before yesterday, we were talking about correlation. Correlation is positive or negative, or it could be neutral. We can use correlation. We can also use distance. Or in other words, that's what the clustering algorithm does, guys. These are similarities by distance. Okay, let's take each one of them. Here is Euclidean distance. Back to school, if you go back, if you have 2 points, square root of x2 minus x1 plus y2 minus y1 is what is referred as Euclidean distance. Okay, if you have multiple points, you apply the similar formula. That is how you calculate the distance between 2 points. Once we calculate the distance between 2 points, if the distance is less, they are similar. If the distance is more, they are dissimilar. Is one way to think of it. We will see that in action in a bit, guys. So now here is another thing called Manhattan distance. Manhattan distance is another way of understanding the distance mathematically. It's just using a mod of x1 minus y1 and x2 minus y2 and calculating the distance. Now the thing is, why is it called Manhattan distance is here, this here, put this here. So what is happening is, it seems in Manhattan is like a street, a town, and a city in New York. Imagine if there was somebody standing here and there was another building here, and somebody needs to go from this building to this building. If you were to be a crow, you would fly. You can fly. What is it? This is what is called Euclidean distance. This is nothing but, this is the distance between the 2 points. You can calculate square root of x2 minus x1. You'll be able to get Euclidean distance. But what is the problem in Manhattan is, they are all one-way streets. This is one way. Imagine, let's say this is another one way. This is one-way street. And then let's say take this one. Here is another one way. Here is another one way. And let's say here is another one way. So ideally what is happening is, if somebody wants to go from here to here, the path they would take is, they will come like this, they will go like this, come like this, take like this, go like this. In other words, that's the path they need to go. What is this? This is referred as Manhattan distance. At a mathematical level, it is using a mod. Everybody with me, guys. Quick yes, please. Euclidean is just a straight distance between 2 points. That's what we've been used to in school, guys. You can force an algorithm to use either Manhattan or Euclidean distance, or you can also tell it to use cosine. Cosine is nothing but a dot product. It is acting like a dot product. More precisely, what cosine does is, if there are 2 points, what it can do is it can come up with theta. It can calculate the theta, the angle, and if you remember, cos 0 is 1, cos 90 is 0, cos 180 is minus 1. So, if what is 1, 0, minus 1? If it is between 0 and 1, it is positive correlation. If it is between 0 and minus 1, it is negative correlation. So if it is positive correlation, means they are related. They are very close to each other. If it is negatively correlated, means they are not related to each other. That's another way how it can, that's another mathematical way of how you can understand whether something is positively correlated or negatively correlated, and that's another way of for it to identify it, guys. Next one is Tanimoto distance. Again, I have never really used it, but that is a formula, that is just a FII, guys. You can, again, as I said, you can explicitly tell, but generally you don't tell an algorithm. You can directly go ahead and use the default ones, which is Euclidean distance or the cosine, guys. So let's see, come back here, back to a slightly formal definition of the k-means. K-means, choose this one. Okay, the process by which objects are classified into groups, into a number of groups, so that they are as much dissimilar as possible from one group to another group, but as much similar as possible within each group. They are similar within each group, but they are dissimilar between the groups, is what the message is, guys. One more time. So if you're within the cats, imagine that cats, they're very similar to each other. Between cats and dogs, they're very dissimilar. Between cats and horses, they're dissimilar. Between cats and elephants, they're very dissimilar, is another way. The same thing we are again stating here, we are also again restating here. That is one of the important things about the clustering, guys. Now let's get into a little bit of mathematical details. How does the groups form, or what is happening before these groups are formed? Let's see. So take a look at this. Generally what we do is, when we use this algorithm, we tell it, hey, I want to form 3 groups, or I want to form 4 groups. So here, for the sake of simplicity, we'll say I want to form 4 groups, not 3 groups, although I say that we will form 3 groups. So in other words, first what is happening is, it will take the data, it will plot the data. First step. Imagine all the points are plotted. Then what it will do is, imagine we said we need 4 groups for the sake of simplicity. What it will do is, it will identify 4 points randomly. 4 points randomly, these are called centroids. Okay, now what it will do is, from each centroid to every point, it is calculating the distance. There it is, from each centroid. Now from the first centroid, it will calculate the distance to every point. Okay, now this is where you can use a Euclidean distance, you can use a Manhattan distance, you can use a cosine, you can use a Tanimoto, and there are some other options. But as I said, anything is okay. So now once it calculates the distance to that centroid, okay, now repeats that with this centroid. Calculate from here to every point. Then repeat that for the third one. Again, once that is done, it will repeat it with the fourth centroid. Now what it does is, once it calculates the distances, all the points which are most closest to this centroid. Let's say you take this point. This point, this bubble, is, let us say, most closest. Its distance is most closest to this one, then this one, then this one, then this one. What do you do? Well, it will say this belongs to this centroid, and what will it do? It will form a group. It will be part of that group. So in other words, all those bubbles or the points which are closest to this particular centroid will be formed as one group. Next, what will happen? The same process will repeat for the brown. Next, the same process will repeat for the reds. The same process will repeat for the greens. Okay, so let's say, choose that. Now, what is it now? It looks like 4 groups are formed. But what will it do? It will not stop here. What it will do is, it will take each group, and now what it does is, it will take all the x coordinates of all these bubbles. It will take a mean or a median, calculate the mean or a median. You will get a new mean, or that will become the new x1. then it will take all the y's and it will calculate mean or median. That will become new y1. So what is happening is that new x1 y1, let us say, ends up here. So what does it do? Now what it does is that becomes the new centroid. This is no longer the centroid, but for the green one, that becomes the new centroid. Next, come to the red one, the red group. What it does is it will take all the reds, calculate the mean and median of the x and y in a similar fashion. Let's say what will happen now, it comes up there. So what is it? This is no longer the centroid, the group is removed. Repeat that for the blue one. Let's choose this one. And let's say the blue one comes up here. So that becomes the new centroid. Delete this group, remove the group. Repeat the same thing for this one, get rid of this one, get rid of this one, get rid of this one. And now for the pink one, let's say use this one. It moved here. Pink one almost looks similar to red, so let's give it a black. Okay, so what did we say? We say this centroid has moved from here to here. This has moved from here to here. This has moved from here to here. This has moved from here to here. Everybody with me, guys? Everybody understand this point? Can you give me a quick yes? In each group, we are taking all the x and y's, we are taking the median, and now we are mean or median of the x and y's, and now we are saying these are the new centroids. So now what happens is the process repeats. What does that mean? Well, from this centroid, calculate the distance to every point. Okay? And then, what do you do? Repeat the step with this one. Every point. Then repeat it with the third centroid. Just this one, then repeat it with the fourth one. Then what do you do? Start forming the group. Now, again form a group. So when you form this group, now what can happen is, imagine all the pings. Now, let's say these points are close. So earlier, what happened is these pings were part of this centroid, but now they are part of a new centroid. In other words, the new groups have new points. New colors are getting into new groups. Everybody catching that point, guys? Can you give me a quick yes? What were all the pinks were in one group? Now, not all the pinks will not be given to this centroid, but they may end up in a different group because their distances vary. Similarly, let's say choose let's say the blue one. For the blue one, these may be close. And for the red one, let's say choose this one. These may end up being close. And for the green one, these may end up being the close. So now the new groups have formed and new bubbles, new points are getting allocated. Now what will happen? It will repeat the process again. What is that? Which is, let's say, start with this one. Again, it will take all these things, calculate the new mean and median. Let's say now the green comes up here. What will happen? The green will come up here, let us say. The red is coming up here, and let's say the blue is coming up here, and the last one is black one comes up here. Oops, so do that. Choose black. Black one comes up here. So that's the black group, and the group this may move. Oops. So again, oops, let's move here. Say, of that one. Say this becomes the green group. And these become the red group, and the remaining one, let's say, is blue. The remaining form the blue group. And what does it do? Again, it will repeat. So what is happening? Take a look at this. Let's move one step ahead. Come here. First visualize when it formed the first centroids. They were here. Choose this one. Choose this one. This is centroid, first centroid, second centroid. Is the third and the fourth. This is in the first iteration. We call that as the first iteration. In the second iteration, the centroid which was here has moved from here to here because of the way it is calculating. The brown which was here has moved from here to here. The red which was here has moved here, and the green which was here has moved from here to here. Now what will happen? The process is again repeating. It will repeat here. It will repeat. There comes a stage after a few iterations where when new groups are formed, the same group of points are getting allocated to the same centroids, and there is no change in the groups. What were the points or the bubbles in the previous group? The same group of points are getting reallocated to the same thing. This is called a stage of convergence. This is called a stage of stabilization. Everybody catching it, guys? Can you give me a quick yes? In other words, the groups are not getting reallocated, or the groups are not getting any new points, but they're just getting the previous points. That is called a stage of convergence, and that's where it stops. And when you stop it, what do? That's where you will understand what's it doing. At a mathematical level, all the cats are being put together. All the cats are appearing at one place, all the dogs are appearing at one place, and let's say for the sake of simplicity, this is the, let's choose another color. This is, let's say, all the giraffes are separated, and let's say, take this one, all the elephants are separated. What's it? Based on the principles of mathematics, we have separated the cats, dogs, giraffes, and elephants. What is that? That is clustering. One more time, quick yes please, everybody with me. We'll now get into a little bit of practical and get a touch of it, guys, okay? So let's see, come back here. Take a look at this data. Some data from e-commerce scenario, and let's see what we have. So here is a customer ID, the genre, the age, annual income, and spending score. Okay, so take a look at this guy. This customer is 19 years. On the whole, if you go all the way down, we have close to 200 customers data. This is a male. He's 19 years old. His income is $15,000 US data. Okay, and his spending score is 39, which means if he has $100, he spends about $39 for every $100 that he has. Take a look at the next guy. He's 21 years old. $15,000 is income. 81. $100 is spending 81. Then take a look at this guy. This spends only $6 for every $100. He's also around 20 years age. Like this, we have 200 customers data. Everybody okay with that? Quick case. Okay, now what we want to do is we want to find some patterns in this data. Okay, so if you recall, what do? We don't do anything. You just take the data, give it to the algorithm. Let's see what that means. Come back here. Back to here. And let me bring up my Jupyter, which is going to be this one. So let's start with some imports. NumPy, if you recall, that is a package for arrays and matrices. Matplotlib is a package for visualization. Pandas is a package for data frames. Seaborn is an advanced package for visualization. We did not cover due to some time issues, guys. Okay. So now we're telling os.chdr, we're telling our Jupyter, hey, point to this particular directory. I have already done that, but for the sake of discipline, let's run it one more time. So there it is. So now you can say get CWD. Show me where you're pointing to. It will say it is pointing to our data sets. Why? We have our file there. All customers CSV is there. So here is sklearn. If you recall, sklearn is a package for machine learning. You don't need to by heart them, guys, but you need to be familiar. If you practice it a few times, you will automatically be able to understand, and you will be able to tell yourself these package names and things like that. The first step is do read CSV. Read CSV. It reads the file and creates a data frame. We're going to rename that as df for sake of simplicity. So here is df. Say df.head. Look at this, customer ID, genre, annual income, spending score. What is head? Head, if you recall, gives the top 5 rows. Everybody with me? Quick yes, please. CHDR is changing directory. You're telling Jupyter to point to that directory because that is the directory where you have your file. That is generally the method and the process. Then generally what we do a tail. Tail. Look at the last 5, get a feel of your data. Then you also look at df.info. Info is telling you, hey, it looks like 200, or everything is 200, so no missing data. So not a lot of pre-processing. This is already where pre-processing is done. Okay, and we try to understand whether it is treating int means it is numerical data, object means it is textual data. Okay, that is genre. Genre is whether they are male or female. That is textual data. Age, income, and spending score is taken as the numerical data. Then, for sake of discipline, let's say df dot. Let's describe. So there it is. This is the descriptive statistics or the basic statistics. Generally, let's say come back here. For an ID, you don't really need the descriptive statistics. They don't really it's not insightful. Your minimum ID is 1. Your maximum ID is, what is it, 200. Your average ID, that is not really meaningful. Okay, so ID, for customer ID, you don't need to worry about the statistics. They're not really insightful. Take a look at the age. Minimum is, it looks like our customers who are visiting our mall are anywhere from 18 years to 70 years. On an average, age seems to be 40 years. There are totally 200 of them. That is roughly the standard deviation of the variance. And here is the median. Median is 36, so 36 is roughly the average age, is what you can think. Everybody with me, guys? Catching it? This is generally the method. This is generally the process here. We are trying to understand some basic statistics. These are also referred as the descriptive statistics. Descriptive statistics is where you're trying to get a feel of the data. You're trying to understand the min, max, first quartile, second quartile, third quartile. This is generally the standard procedure. As a data scientist, as an AI professional, these are some of the things that you do for almost for every data set and get a feel of the data, guys. Then come to, what is this one? This is income. I think the header is hidden there. But notice what is happening is, it looks like our customers are making anywhere from $15,000 to $78,000. On an average, $60,000 is their income. So the median is also 61, roughly. What is that? That is, so you again, as I said, you're getting a feel. Okay, the customers who come to our mall are making this much salary, is what you're understanding. Then the spending score. Spending score, the minimum is 1. Some customers are spending only $1 for every $1 for every $100. Or you can think in terms of rupees, they spend only 1 rupee for every 100 rupees that they have. They come to the mall, they spend 1 rupee, guys, for every 100 rupees they have. For me, that is very minimal. Why would somebody come and spend one rupee? Well, we don't know, but that is what is coming out here. Some people, maximum, they're spending 73. So it doesn't look like there's anybody who comes with 100 rupees and spend all the 100 rupees. So they are saving some money. On an average, it looks like, notice, 50 rupees. That is the mean. Median is 34. So somewhere around 34 to 50, they're spending for every 100 rupees, $100 that they have. Everybody with me, guys? Quick yes, please. Now that is slightly interesting, slightly insightful. It is not the greatest insight, but that is slightly insightful. It is interesting to know. When business hears this kind of things, they would love, they'll fall in love with you, even though they are not the greatest insights with you, guys. That's why they're looking for the data scientists and the AI professionals, because they give this kind of business information. But let's see, let's go into a slightly more sophisticated ones. Oh, my bad. Take a look at this, guys. Actually, if you go back here, the maximum they're spending is 99. My bad. I was actually looking at this one. Okay, so let's tell, if I clean up a little bit, if you come back to income, they make anywhere, customers' income is $15,000 to $137,000. Okay, and how much are they spending? Some, they're spending only 1. Some, they spend 99 out of $100 they have. That's what I was wondering, why it was coming to be 73. And I was a little puzzled myself, but there it is. In other words, some people spend all the money, almost all the money that they have. That is what is slightly interesting, guys. So now let's move on to the next one. Take a look at this. What we are doing is, if you remember df.drop, customer ID. Generally what we do is, customer ID is not used for analysis. If you want, if there are a group of students in a class, based on their roll numbers, you don't try to find anything insightful. So what you don't consider their roll number. How many marks a student will score, whether they will pass or fail will not depend on their roll number or the student ID. So you don't consider. So what do? So customer ID is like the roll number. You drop it. Take a look at df.gad. And if you recall, so customer ID is gone. In place equal to true means you are forcing it. Hey, don't create a copy of this and make a change, but make the change in this data frame only. That's what that in place equal to true is doing. So here are some important columns. Now what we'll do, I will not explain every step here. Let's do a quick visualization. Let's see what it does. So this is what is called a Violin plot. Let's see if we can understand something out of this. Violin plot, what it is doing is, it is giving you a box plot. So here is the white color, the white dot is the median, second quartile. Roughly it is saying on an average 35 years is the average age. of the customers who are visiting. This is the first quartile, this is the third quartile, this is the second quartile, and this is the interquartile range. We briefly talked about them. Okay, and because I'll focus on slightly more important, I will not again re-explain all these things, guys. And what is happening is it kind of gives a normal distribution slightly at a statistical level. We have not talked about the distributions that much, but this is giving normal distribution, and majority of them are here in this range at around 35 years roughly. That's why it is so wide there. This is called Violin Plot because it has that look of a violin. You generally try to understand it's a combination of the distribution and the box plot per definition, guys. But that is, again, visualizations is a separate thing I have not covered in detail, but I'm just giving you a feel of the kind of work that we will be doing, guys. Next, come to genders. Let's see what this does. Okay. Here is value counts. What is value? Notice out of 200 customers, 112 customers are female and male are 88. So the majority of the customers are female. Can you think of a reason why more females are visiting a mall than the male customers, guys? Gaussian. Srikant, that is true, buddy. That's a Gaussian distribution. But can you think of any reasons why more females visit malls than males, guys? Any thoughts? Any friendly thoughts? You don't have to be 100% precise. They are shopaholics. They like shopping. They love shopping. Good one there. Home needs, good one there. Males are at work. Good. Yeah, even females are at work, but they like more shopping. They are, they're shoppers. So as simple as that. They like more makeup, window shopping, and things like that, guys. So now, what do we do? Generally, when we do value count, go ahead and show bar plot. It's a characteristic of a data scientist. What is it? Whenever you have some kind of data like this, picturize it. So notice you just give them a field. More females than males is what we have in our group of customers, guys. It's a characteristic of a data science. Then let's see what we have here. Here is what is called box plot. One more time. Spending score and the annual income. So if we come here, choose this one. So take a look at this. The mid one is the median, second quartile. That's about spending score is 50. On an average, again, one more time, we are getting a feel of descriptive statistics or basic statistics in a slightly visual way. What is this one? On an average, people are spending 50 rupees or $50 for every 100 rupees or $100 they have. And it looks like their average salary is close to 60,000 rupees or maybe $60,000. And notice some are outliers. Outliers means they are greater than 3 standard deviations. Again, a little bit of basic statistics and things like that, but we'll focus on slightly different topics for today, guys. So you try to understand the interquartile range. Is that too wide or is that too less? Is what you try to get a feel of it. Okay, so that's another visualization we are looking. And what is this? This is box plot. What is box plot, guys? This is again spending score, numerical data. That is numerical data. If you have only one column, you're trying to visualize that. Then you use a box plot, guys. That is one way to remember it. And now take a look at this, guys. Here is, we will go to our data frame, take all the customers who are between 25 and 18. Take all the customers who are between 26 and 35 and more bins. So these are some bins. And here is why. Let's see what this looks like. If you run this, notice it looks like this. Okay, it looks like majority of the customers seem to be between, so this is taking a slightly right skew in terms of a statistical this thing, but majority of the customers are between the ages 26 and 35. Can you think of a reason why majority of the customers between 26 and 35 are visiting the mall, guys? Females can bargain. Nice one, Hemant. That's a good one. Okay. Why do you think majority of the customers are between 26 and 35? Why do they visit the mall more? They're recently married. Okay, good one there. They're young. They're young. They're single. Good one there, guys. Interesting. They're couples, young couples. Combination. They know what to buy. Good one there. Okay, some good answers coming up there. Some of them fashion wear. They're more fashion aware. After you get a little old, you don't go into fashion that much. But when you're young and married and things like that, you're more into fashions. You like rocking. They're also greedy. Okay, good ones there, guys. So I will not go into the distribution right now, but that is a kind of, that is not a great insight. but it is an interesting insight that we are observing these guys. A business, what will a business do? They're also attractive. That's a very good point. The business, if they know that, hey, a lot of guys are, this is the age group, maybe they might come up with a plan. The plan is we should probably bring more of these customers, because a lot of customers who are in this age are coming. Maybe we should give them discounts if they're in this age. Or maybe we should not give them any discounts because a lot of them are coming the linear purchase. So they can think like that. Business, if you give them a clue, business people will be able to think in lots of different ways, and they'll be able to come up with different ideas because they are the business experts, they are the domain experts. We are not the domain experts. We report the insights, but they will come up with many insights after we do the reporting, guys. So that's a little bit of exploration. The visualization is part of the exploratory EDA, exploratory data analysis. But let's go back to our data set one more time and see what else we can do. Back to the data set. Now what we are going to do is we are going to go to this data set. We are going to say, take all the rows, take only the third and the fourth, which is the fourth and the fifth, and convert it to NumPy array. Which means we are only taking the income and the spending score. We'll start with two columns, the income and the spending, how much they're earning and how much they're spending. And now, for the sake of simplicity, we'll create an object of data frame, the same thing. So there it is. This is the income column and this is the spending column. Okay. Now, what we'll do, we'll create an object of k-means. So touch of object-oriented programming. Imagine, for the sake of discipline, we'll start with 5 clusters. We're saying, hey, we're telling the algorithm I need 5 groups. And these are, for now, think of them as random, the default values. So let's copy them here, put them here. So what did we do? We created an object of k-means. Next, what we should do, we should call fit. The method fit is where the mathematics, statistics, and probability of the algorithm is getting triggered. When you start a car, petrol gets converted to electricity. This is where it is happening. All the mathematical steps that we have discussed happen when you fit. As I said, fit. You keep hearing it a lot in Python machine learning world, guys. Now, let's see what that does, guys. Okay, I will not explain every line here. This is more of a matplotlib thing, but let's see what is happening here. Take a look at this one. Say, get rid of this one here. Put this here. See if I can put that in one screen. Annual income, one more time. And here is the clusters of customers. So we'll put it like this. And let's say come back here. Pardon me. So now let's start with this one. Take a look at these light blues. What's happening in the light blues, guys? Notice these are the group of customers. Their annual income is anywhere from $20,000 to $40,000. Okay, that's what they make per year. And what are they doing? They are spending anywhere from $0 to $40 for every $100 that they have. This is their spending power. Okay, next come to the pink ones. Let's say we'll use this one. What's happening? These guys, majority of them are here. They're anywhere from $70,000 to, let's say, $100,000 is what they're earning. And what are they doing? Their spending is similar to these guys. They spend only from $0 to $40 is what it is. Okay, then next come to the, let's choose, let's say green one. We'll choose green one here for the blues. Notice these guys are anywhere from $40,000 to $60,000 they earn. And what's happening? They spend anywhere from 40 to 60 for every $100 they have. Then come to the red ones. Red one, let's use this one. Notice majority of them are here. They are earning only $20,000 to $40,000, but notice they are spending $80 to $100 for every $100 they have. That is, what are these? These are called characteristics of these customers. Then come to the final one. Let's say, which one is left here? Let's choose the blue one. Majority of them are here. These is, again, they're similar to the yellow ones in terms of earning. What are they? They're earning anywhere from $80 to $100,000, and notice they're similar to the reds, which is here. They are also spending anywhere from $80 to $100. In other words, this is a group. They're earning more and spending more. Okay. Come to the black one or the red ones, the dark red ones. These are the groups. They're earning less. Their earnings are less. But what is happening? Their spending is more. Okay. Then come to this one. The light blues. These guys, What is special about them? They're earning less and spending less. And if you come here, these guys, they're earning more but they're spending less. You come here, these guys, they're some. Everybody with me, guys. Quick yes, please. Okay. So now, what is this? We are calling them as clusters. But for the sake of simplicity, in a real world, what will happen is we will actually explain this to the business. And what will the business do? This is what the business will do. Come back here. Back here. Say here. All this kind of information. This here. Scroll down. It's here. Now notice what the business is telling. And they'll say, oops, not this one. Back here. Back to here. Put this here. And start with this one. So take a look at this. They're calling the light blue customers as sensible customers. They're calling them as sensible customers because they're earning less, they're spending less. Their earnings is less and spending is less. Next come to the pinks. The pinks are called as careful customers. Why? They're earning more, but their spending is less. That is the story of the careful customers. Now, next come to the blues. They are being called as the standard customers. Why? Their earnings are average, their spending is also somewhere in the middle, average guys. Next come to the reds. What's happening with the reds? Reds are earning is less, but spending is more. So these are the careless customers. They're going to call them as careless customers. Next come to the last one. Choose this one. What is this? Their earnings is more and spending is more. These guys are called as a target customers. Everybody with me, guys. Quick yes, please. What is this? This is what the business is calling them. We call them as group 1, group 2, cluster 1, cluster 2 and things like that. But what is it? That is being. Now business is able to understand who is sensible versus who is careful versus target versus standard and careless. Now in what way do you think if a business knows that there are a group of customers, they are sensible customers, what do you think business can do out of that, guys? Can you take a guess? Imagine Jayalakshmi is one of the sensible customers. Imagine you own a Reebok shop or a Nike shop. What can you do? Let's say Jayalakshmi is entering our shop. We know she's a sensible customer based on our analytics. What can you do? What do you think we can do a Reebok or Nike store will do with her? Cost effective, good one. So in other words, we know she's earning less, she's also spending less. So what will, if you give her a very expensive product, she'll not buy because her earnings is less and spending is. What should we give? Maybe we should give her a discount. Okay. Next, let's say, come back here. Let's take Shakila. Shakila is a careful customer for sake of simplicity. She is now entering the Reebok or the Nike shoes. So what will they do, guys? What do you think they will do with Shakila? Because she's a careful. You can give her a discount too. Okay, because she's careful. She earns more. She has money, but she doesn't spend. Okay, and what can you do? You can probably also show her some expensive products. Why? Because she has money. Even though she doesn't spend, she has money. You show some expensive products and give her discount also. Everybody with me, guys. Quick yes, please. You give her lots of offers because she has money. Then come to standard. Let's see who do we have here. Let's say Bhuvna. Bhuvna is, let's say, standard. She's somewhere in the average. Her earnings are average and her spending is also. What should we do with an average customer? Budget friendly. Good one there. Offers are all or a different kind of an offer. Because she's an offer is in an average range, she's a different kind of an offer. Let's come to the careless. Let's see who do we have here. Let's take Madhuri. Madhuri is a careless customer. What shall we do with Madhuri, guys? She's earning more, she's earning less but spending more. What shall we do? High price, good one. Okay. Don't give discount. Okay, good one. There you go. Gentlemen, ladies, you tell this kind of things to business. Business will come up with lots and lots of ideas. They exactly know what to do. The thing they don't know is how to identify who are the customers who are careless or careful. And now here comes the most important group, which is a target. What do we do with the target? They're earning more, and also there is the luxury products, costly items, expensive items. You can give them much more quality and highly priced items and things like that. Who are you? You are just common people. If you can think of so many things, business can think many things. Everybody with me, guys? So what are these? These are what is called as a hidden patterns. What is this? This is the story of the data. What is this? This is what you're expected to do. You don't have to be perfect, but these are some of the principal concepts you're supposed to be familiar, and this is what you will be doing in a real world. Everybody with me, guys? Quick yes, please. Okay, now let's see. Let's go one step ahead. And pardon me. Okay. So now take a look at this, guys. Data set clusters, k-means. If you come back here, k-means is an object. What is k-means? K-means is an object of our algorithm. Now what we'll do, we'll ask the centers. There is something called cluster centers. And let's say I think the yellow colors were there earlier, but let me show it to you. Let me come back here. Okay, what are these cluster centers? If you scroll up here, notice these yellow bubbles or circles in the middle. These are called centroids. What are they? This is what the centroids are. At a numerical or a mathematical level, the first group, what this is telling is, let's say come here, choose this one, put this here. The first group is, this is their average income. They're about making $25,000 every year. They're spending about close to $80, which means their earnings, their income is less, but spending is more. Okay, so if we come back here, who are the guys whose income is less and spending more, guys? Who are they in these? They are the careless guys. What is special about the careless? Their earnings are anywhere around $25,000 on an average, and their spending is 80. Next, come to the next one. So choose this one. They're somewhere around, income is 55, and the spending is close to 50. In other words, they're somewhere in the average range. They're somewhere in the average, their income and let's see who are the average here, guys. They are the standard. Okay, what is special about them? Well, that is their average income and average spending. Next, let's say scroll down here. Let's come to the next one. What is this one? These guys, notice their income is high, and also their spending is high, and that is our most favorite group. Who are they? Pardon me, target guys. And next, come to the next one. Let's say, not this one, we have chosen that one. Let's choose the yellow. Okay, these guys, their income is low, their spending is also low. Let's see who they are. Who are they, guys? Sensible customers. Okay, next, the last one is their income is high. Their income is high, but their spending is low. What are they, guys? They are the careful. What are these? These are called the characteristics. What is this? We are not only able to tell a story, but we are also able to understand the characteristics, the numerical characteristics of these guys. What is their average age and things like that? What is their average income? What is their average spending? So ideally, if you're an insurance company, if you know, what can you do? You can come up with a separate plan for these guys versus these guys versus these guys, and so on. If you're a banking company, for a bank, what would be the important? I think this one would be the target would be important for any domain. This is the goal. Being able to understand your target customers is finding the goal. And what is that? If you know these customers can buy anything, costly buy things and things like that, any new product which comes in will go to the target. They will send an email, they will call them, they will give them special offers, much more offers, and for the rest of the group, they will come up with different kinds of plans and things like that. Everybody with me, guys? Quick yes, please. Okay, that's what the business does, guys. So, okay. So now probably what we'll do, guys, this concept I will save it for tomorrow, guys. There's another thing that I would like to explain, which is a three-dimensional thing. We have only taken a two-dimensional approach. Let's take a three-dimensional approach. Let's save it for tomorrow. And the program part. In the program part, the matplotlib part of it, I'm skipping it, guys. But the rest of it is just data frames and creating an object. You're creating an object, you're calling fit here, then there is your creating a data frame, extracting two-dimensional columns there. That's what is coming up there, guys. We'll relook at it one more time tomorrow with the three-dimensional thing. So we'll give it a little bit of time for you to digest and things like that. Probably today it'll become a little too heavy for you guys. Okay? Yeah. Tomorrow I'll be updating it, Lavanya. Everything I'll be updating tomorrow because tomorrow will be there. So, gentlemen, ladies, let's open it up for a few questions and things like that, guys. Good, Srikam. Good to know. Like in k-means plus plus. So k-means plus plus is a default, guys. So if you go a little bit deep into k-means, what happens is there is a problem in k-means. Sometimes what is happening is at the time of forming the clusters, generally what happens is k-means runs a few iterations. It will not reach the stage of convergence or stabilization soon. But very few times it reaches the stage of convergence, maybe in less than 1, 2 or 3 iterations it reaches a stage of convergence. But what is happening there? If it reaches the stage of convergence very, very early, that is not a lot of processing. We don't want it to reach it so early. So when you say in the argument, when you give k-means plus plus, k-means plus plus is an advanced k-means. At an algorithmic level, it is the next generation or advanced level of k-means, where what it is doing is it is making sure it does not reach the stage of convergence until a few number of iterations are run. Okay, we can also give iterations equal to 300 as an argument. So you tell, hey, run at least 300 iterations before you reach the stage of convergence. That is what the k-means plus plus is doing. Slightly deep there. K-nearest, okay, k-nearest probably I'll introduce you. We'll talk about that in the coming up. Elbow method also I'll talk tomorrow, Jaswant. Elbow method and a three-dimensional look I'll talk tomorrow. Good that you reminded me. Random state is 42. I'll save it for the coming up days, funny. It's a simple thing. It is more about reproducibility, but we'll discuss it at the right time. Okay. You can also use Seaborn. We are using a combination of Seaborn and Matplotlib. It's just that these are two vast subjects that I can take in a short time, and I need to focus on the machine learning, so I'm skipping them. My objective is later, once you get an idea of how things work, you will get motivated to learn that kind of things by yourself also, guys. So that's why I'm not going into those things. Manhattan, ideally, I would not even worry about Manhattan or Euclidean. You can leave it to the algorithm. By default, it uses Euclidean. There should be some arguments which allow you to explicitly say use Manhattan. You can also give that argument and say use Manhattan and see if you're able to tell a better story. Muhammad, if you're able to use Manhattan, you see some better story developing, then that's when you want to go with that. That is my understanding, buddy. I have never really explicitly used Manhattan. Clustering is a global. I mean, this algorithm can be used globally. You can take any data. You can go home, take your own data. What you need to do is, again, every algorithm that we are looking at is your E is equal to MC square. When you take stock market data, yeah, okay, you can also apply it there. You can understand different characteristics of the stocks. Which are the stocks which are going up at particular periods of time. On certain days they go up, on certain days they come down. So what you need to do is you need to put your data together like that, Santosh. And that's where a little bit of thinking needs to be done. Oh, yeah, Lavanya. On a daily basis, I'm getting too hooked up. Lavanya, my apologies about that, because I'm working on another place, so I'm unable to give you exercises on a daily basis. But I do have it in mind. I will try to pass on some exercises to you. Are the clusters here before considering the distance? No. Clusters are formed considering the distance. Based on the distance, the clusters are being formed, not before the distance. First point is you come up with a random centroid, then immediately you're calculating the distance, and then you're forming the cluster based on the points which are closest to the centroid. So the first step is you calculate the distance. The second step is you form the cluster. If that is answering your question. Whoever that asked, guys. Okay. Oh, good to know, Bala. Good to know. You're finding it interesting. Yeah. That's why it's called the sexiest job of the 21st century. If you're a Java or a .NET programmer, you're never looking at colors like that in your life. Or in other words, you don't focus on the colors. Here you focus on the colors and you tell a story. Being able to tell something like that is what is the characteristic of a data scientist. We focus on the colors. Colors is what makes the job very, very, interesting. And you feel like working on it. You wake up and you feel like, working on these things and so on. Things like that. Oh, good. Okay, good one, Vinod. Some good words coming up there. Elbow curve, as I said, Srikanth, I'll cover that tomorrow. Santosh, thank you, buddy. How to calculate the unknown distance integral. You don't calculate, Srikanth. It is the algorithm which is calculating. Sometimes there are outliers. And what happens is, you can remove the outliers. You like coding? Very good, Lavanya. Good to know. Keep it up. You don't have to fall in love with coding, guys, but coding is becoming a global skill, and that will really help you in your life, guys. In the coming up days, in the coming up years, in the coming up generation, you don't have to fall in love with it, but give it some time. You at least like it, and it will definitely help you. It will increase your salary, it will increase your quality of life and things like that. So just always keep that in the mind, guys. Coding is becoming important today. It is being introduced in the schools also, so that by the time the children grow up, they're familiar with coding and things like that, guys. Python is one of the best, Srijan. Python. That is the best. It is not because I'm into it. I'm into Java, I'm into .NET, I'm into R, I'm into Python also, guys. It's PDF here. PDF material is being shared, guys. Sushma, PDF. Thank you, Srivali. And VC++ fast. No, you don't even need to worry. VC++ is fast. Python is a wrapper of many of the C and C++ code, Srikanth. But again, we tend to be at a very high level. If you're really involved in a real time, of course, VC++ can come to your rescue. I have never really worked, but Python can also help you unless you are in a business or a domain where it really needs a very, very fast performance and things like that, guys. But Python is also used. Python is much more simpler, Tarun, much more simpler, much more friendlier compared to many other things. What you're seeing, the slicing and dicing concepts and things like that, will take very, very short lines of code. Decision trees are coming up in coming up days, next week. Okay, we'll also try to make it interesting, and hopefully that will motivate you into going into the details of these topics, and hopefully you will upskill yourself more and prepare yourselves, guys. That is what is the objective. Where I cannot make you Sachin Tendulkar by the end of this, but I would like to focus you. I would like to motivate you to learn how to hit the 4s and 6s. Almost every day I will be touching one algorithm, Jyotsna. Very good, guys. Jayalakshmi, thank you again for all those good and kind words. Keep it up. More importantly, revisit the recordings and try to kind of get a feel of them. And if time permits, get more into the details during your free time, guys. Code by seeing the video. Yes. Sai, I'll be sharing it, as I said. I'll be sharing the code. You need to give a little time for me. Final exam will be taken by Mansa and the team, guys. I will leave it to her. She will get back to you on that. These are all real-time case studies, Vamsi. This is how the real-time things work. I'm taking bits and pieces of various real-time works and introducing you. But in a single project, everything that will take may take much more time, guys. Grouping similar kinds of items. So that is right, Sindhu. Within a group, all the items are very similar. Between the groups, they are dissimilar. Kumar, thank you, buddy. How can you know which algorithm to use? We'll discuss that. Okay? Any platform. Start with Anaconda. Sheikh, Shakila. Start with what we are doing here. As simple as that. Jupyter is your most simplest and easiest thing to start with. If you go to Google is your friend, guys, you can find a lot of help on Google. You start with Google, Google, YouTube. These are some places where you can start with if you want to learn Python basics. Naresh IT themselves are offering a free course of complete Python, guys. You may want to follow up with them. I think it's at 11 a.m. in the morning, I think, guys. Please check with the folks. Yes, you can also be a data analyst, data scientist. Data analyst is, a part of data scientist, guys. Okay. Programming. Yeah, for a little bit of programming, we covered a little bit of programming. Obviously, programming is Notion, guys. Like we cannot cover programming in 1 or 2 weeks. So you also take some additional courses. Some of them are being offered free. That will also help you in catching up more. Whatever is a little bit of programming required for these things, that's what I have already covered some topics, guys. Okay. Okay. Very nice, Pujita. Submit every day. Let's give 5 more minutes, guys, for more questions and things like that. Then I will wrap up. Mansa will be taking over. So let's see if there are more questions. Thank you, Ashok. I appreciate it. If you're getting motivated, that is what is the purpose, guys. Tomorrow, we'll extend this one to 3 dimensions and we'll also look at a slightly advanced topic called elbow curve. Elbow curve is here. Today, what we have done is we have manually picked up 5 groups. But there's a mathematical way of understanding what is the optimal number of groups, guys. That is what is elbow curve does. Tarun, thank you, buddy. Great. Good. Ajay, thank you. And available will jobs of kinds. So course ML and joining ML AI. Yeah, almost every job will be requiring an AI or machine learning and deep learning knowledge in the coming up days and the coming up years, guys. That's why we are introducing these topics to you. So you should look more if you have time and things like that. You should try to learn more and you should try to find jobs. Obviously, we cannot guarantee you the jobs, but we can upskill you. This is Rajesh. Without labels, this is called unsupervised learning, guys. That's a good question, guys. I'm probably going to stress you a little bit with this question. Yesterday, if you remember, yesterday and day before yesterday when we were discussing simple linear regression, multiple linear regression, one of the steps that we have done is we were splitting the data, we were dividing the data, we were partitioning the data. Today, we just took the data and gave it to the algorithm. We did not split it, we did not partition it. What is this? This is called unsupervised learning. Yesterday, imagine we had a scenario of a tutor and a student. The tutor is supervising the student. That's where he's hiding some of the questions, he's making sure he understands the concepts. Today, what did we do? Today, imagine tutor comes in and let's say Srikanth is the tutor and Ravi is a student. Today, what Srikanth is doing is he's not supervising him. He's just giving it to a group of questions to Ravi and he's asking him to separate the questions. He's let's say asking Ravi, can you separate all the maths, physics, chemistry and biology questions? He's not supervising. So this is called unsupervised. So Srikanth doesn't need to test Ravi. This is called unsupervised learning, guys. 3 years gap. Can I get a job after the many years of gap by having knowledge of? You should try, Sindhu. If you're good in the skills, that is more important. Very good, Santosh. Keep it up, buddy. Fit is where the mathematics of the algorithm is happening. In short, Ajay. In the world of Python, machine learning, AI, ML, they'll keep using that fit. That's where the algorithm is performing its mathematics. We don't do the mathematics. We call the right algorithm. And we'll try to understand when to call the right algorithm. Okay. Lata, I got your thing. Interview questions, that's going to be a whole new thing. So if you remember the concepts, these concepts will definitely be covered in interviews and things like that, Lata. Short answer. Okay. Okay. So gentlemen, ladies, at 8:45 I need to get out, guys. So I will be signing off here I will be leaving it to Mansa for the feedback and other kinds of things, non-technical things. She'll be handling it from here, guys. And thank you, guys. You guys take care. We'll continue the journey tomorrow. Everybody, please make sure you guys are staying safe and keep learning, guys. Thank you, guys, again, and bye for now. Thank you.